we work with a lot of different industries, and there's a lot that's different about those. There's a lot that's in common too. So I'm going to give you kind of a product lifecycle view of developing, building, delivering, using, servicing a product, and how some of these terms fit into that, I think, right? So I'm going to use the model-based paradigm of that, but let's just walk through that life cycle. So I think in product development, we start from the voice of the customer all the way at the far left. And from that, we try and understand what they want and translate that into the requirements that we need. If we're being robust about this, really, this is the model-based systems engineering discipline. It's collecting and understanding the requirements, making them granular, making them accurate, subdividing them, deriving them, breaking them down, then developing functional and logical models based on those so we can get to a physical product design or multiples and do some trade studies across them. But that's that whole MBSE discipline that we start with. From there, we move into the different design disciplines or domains potentially. Maybe our product is mechanical only, but if it's got multiple disciplines or domains within the product design, maybe there's an electrical model, there's a software model, but that's all the MBD area, right? And from there, we move into engineering. Now, there's, of course, engineering related throughout this, but let's just add that on as the next layer and say the simulation, the analysis, the calculations, all the things that validate that the design is satisfying the requirements is what we think of as model-based engineering. And when we put all of that together in an integrated model, right? And so we've got that electromechanical with code type of model with some of the basic behavioral simulations and things like that. I would call that the virtual product twin, right? So that's where I think this fits. Over in product development, before we've ever made the first one of these, we have a virtual product twin. Well, our next logical step, though, is to think about making it, right? So when we start to think about moving from the product development area over to the factory area, before we actually get into making anything, we do need to plan it. So there's manufacturing and quality things, right? And there's some model-based takes on these that are important to consider that go together to make that virtual process twin. What is the process of how we build our product, right? How do we make the individual components, or how do we source and buy them? How do we assemble them, put them together? How do we test them, assure that they meet the specifications? That's all part of our virtual process twin. All right, now when we've got a plan for the product and a plan for the process of how to build the product, it's time to make it, right? So at physical instantiation, that's the point where we shift over and we're in the factory now making the individual physical instances, those units, right? So unit 1 rolls off the line, unit 2 rolls off the line, unit 3 rolls off the line, until the point where we're starting to deliver these to the customer. Now, I want to mention something about what happens as we're building these. So we had a plan with the virtual process twin, but as we execute that and we use imperfect equipment, or we use one set of equipment in one plant and a different set in another, and some things happen differently on a Monday than they do on a Friday, and maybe our autoclave has a different bake temperature for that composite that we're making. The data that we collect from our plant, from our factory, is important to each of those units, right? So they're built differently on different days of the week. Maybe they're a little bit unique. That's going to matter to us later. So collecting that sensor data, what a lot of people would talk about is industrial Internet of Things data, right? Coming from the sensors off of the machines and the equipment in our plant. That is important to understanding our digital factory twin, right? It's a composite of all the equipment we have, all the processes we're running, our digital perspective of that, but also with the real-time data collected as we've made these different units. All right, let's keep going though. As those products are delivered and they go out into the field, right? Unit 1 and Unit 2, they make it out there and they're being used by customers. Let's take the example of Unit 3, which is out there being used, but then needs some maintenance, some service event, some repair, something like that. So this starts to bring in not only the field area, the products being used in the field, but also the service component when they have to come back in to have some work done on them. There's another area where we have some planning that we need to do, this model-based sustainment activity that would tell us what kind of service we do and get our unit back into the field. But as we look at all this, we say, okay, there's something else sensor-wise, data-wise that matters. So those little sensor icons, yeah, we collected information when it was in the factory, but we're also collecting sensor data when the products are out being used by customers. Now, how many hours a day is it being used? What kind of vibration is it undergoing? All that sensor data is the Internet of Things, so just the regular IoT. When we put all of this together, this is what gets us to the digital twin, right? So if I look at Unit 1 specifically, and I trace back to exactly how it was made, what were the temperature settings on the heat treat machine and that sort of thing in the factory, as well as what are the sensors telling me today when it's used in the field, that IoT data. And all of that traces back to the virtual product twin that made it, exactly how it was configured when it was made that day. And let me throw in one more thing. If we were talking about Unit 3, any repairs or changes or modifications that happened, that whole history is the digital twin, right? All that information comes together to make a digital twin for us. Hopefully that helps.